Today we're going to talk about reflections and rotations. These are both rigid transformations, right? So we're going to talk about reflections and rotations. A reflection is a flip. So we're going to take a point and we're going to flip it over a line. A rotation is we're going to take a point and we're going to rotate it around another point. So those are the two things we're going to be working with today. So first of all, a reflection. Reflection is a transformation in which the figure is reflected from the image to the image of the pre-image. So when we reflect something, remember we're changing the orientation. We're changing it around. So if you look at this shape, we flip it over the line, the point ends up on the top, right? We're the same distance away. Each point is the same distance away from that line, and that's how a reflection works. So if I'm drawing this B, I'm just kind of drawing it like backwards. We flip it over, kind of reflect as an opposite direction, as we know with our cameras. So common reflections are reflecting across the x-axis. So we have our x and y, our x-axis right here. So what happens if we reflect over the x-axis? Well, if I have the point 3, 2, and I reflect it over the x-axis, I come down here to the point 3, negative 2. So what we come up with is our x stays the same and our y changes. Reflecting about the y-axis. Well, here's the y-axis. So this point is now going to go the other way. Notice this one is 3 units away from the y-axis, 3 units away from the y-axis on the other side. So we're going to be at negative 3, 2. Right? Y equals x. Well, y equals x is the line that goes through like 1, 1, 2, 2, 3, 3, 4, 4, so on and so forth. So what happens when we reflect with y equals x is the x and y coordinates switch. So what happens here is the reflection about y equals x is the point 2, 3. Other reflections are over a vertical line. Remember, a vertical line is x equals, all right? A horizontal line is y equals. So vertical line is up and down, horizontal line is left and right. Make sure you get that straight. It's really bad if you have a test and you're supposed to reflect over a vertical line and you make it horizontal. You take a really easy problem and make it much more difficult. All right, so here's kind of a summary of what we just looked at, okay? So common reflections. All right, let's just draw our little diagram here. If I have an XY point, right, XY, and the X turns negative, what do? Well, we flipped it over the Y-axis. We reflect over the Y-axis. If the Y changes coordinates, well, that reflects over the X-axis. If the signs change, well, what happens there? Well, we're reflecting from XY here to negative X and negative Y, all right? Well, what that is a reflection about the origin. Now, what about XY flipping? XY flipping means that we're reflecting over the line y equals x. And if they flip and change the sign, we're reflecting over y equals negative x. Right? So just plug in the coordinates and get the coordinates out of it. So that's all you have to do. So if we're flipping this, so we're drawing the triangle with these vertices. And what we're going to do is change the x coordinate. So let's draw these, negative 2, 4, negative 2, 4, 0, 5, and 2, negative 3, 2, negative 3. It's way down here. So there is my triangle. So this is negative 2, 4. This is A, B, and C. So now we're reflecting, we're changing the x coordinate, which means we're flipping over the y-axis. So A is going to flip over here, A prime, right, to the point. So we're just switching the x, so we're just going to be at 2, 4. B is on the axis, so it just stays the same, and C is flipping over here, so we're now going to be at the point negative 2, negative 3. And we draw our coordinates, and we have reflected it over the y-axis. What would happen if we flipped over the x-axis? Well, the y-coordinates would change. That's all that happens. Okay. So reflect across the y-axis. Here is my y-axis here. And we just flip it. Now, the easy way is if we're 2 away on this side, we're 2 away on this side. So this would be my r prime. And this is going to be at the point 2, 7. Right? If we flip 7, negative 7, 7, it's going to be over here. And we know it's going to be 5 units away. So we're at the point 7, 7. Now, it stays the same shape. It kind of flips over. So the 3, negative 3, 4 is going to be at 3, 4. And the other point, so this is my t prime, and this is my s prime, and we have our reflection. And if you have to label the coordinates, you do that, but notice it flips over. So that's how we deal with that reflection. Reflection across the x-axis, same thing. We're 4 units away, so you could look at this. We're going to be 4 units below, come across. We went 3 up there, and we just draw it like that. That's our flip. So this would be my q prime, which would be at negative 7 now, and so on and so forth. We got r prime, t prime, s prime is where those values would be. Now, if you reflect across y equals x, a little trickier. What happens is the coordinates flip. So r prime is now at 7, negative 2. So 7, negative 2, we're going to go on our x-axis over to 7, down 2. So there's my r prime. My t prime is going to be at the point 4, negative 3. I'm going to go over 4, down 3. There's my t prime. My s prime is at 4, negative 8. So we're over 4, down 8. There's my s prime. This is my t prime. This is my r prime. And my q prime is going to be right here. And we'll draw our shape. Notice it looks a little different. Because we've reflected it over y equals x. What that means is if I draw t and t prime, this is a perpendicular, and then these two segments would be congruent. And that's what we mean when we reflect over y equals x. So just some examples of some common reflections. Now, rotations. Rotations can be a little trickier. So we rotate around a fixed point, and that is the center of rotation. So how do we rotate? Well, if we go in this direction, that is clockwise. It's the way the clock goes. If we go in the other direction, we call that counterclockwise. So we go in this way, it's called counterclockwise. So ABC rotates counterclockwise 90 degrees or 270 degrees clockwise, or 90 degrees counterclockwise. Notice those two add up to 360. Each quadrant is 90 degrees. So label our quadrants, right? This is quadrant 1, This is quadrant 2, this is quadrant 3, this is quadrant 4. Each quadrant is 90 degrees away from each other. So if I go from 1 to 4 or 1 to 2, we're going 90 degrees. If I go 1 to 3, it's 180 degrees. So we should know that. So the image is ABC, and make sure we label. So let's just make a triangle, and we'll talk about our rotations. So let's take a look. 90 degrees about the origin. So we go about the origin. So if I have points over here, we rotate 90 degrees about the origin. We go 90 degrees in this direction would be clockwise. 90 degrees would be counterclockwise. Notice 90 degrees moves every point one quadrant over. So we just move one quadrant over. 180 degrees goes into the opposite quadrant no matter which way we go. To the opposite quadrant no matter which way we go. And then 270 degrees is going to take us all the way around to the next quadrant next to it. So 270s and 90s are very similar because you're going to end up in the next quadrant over. So each quadrant is 90 degrees. So here's the way I look at it. So remember our quadrants. Quadrant 1, 2, 3, and 4. In quadrant 1, the signs of x and y are plus plus. In quadrant 2, x is negative, y is positive. Quadrant 3, both x and y are negative. And quadrant 4, x is positive and y is negative. So if you remember the signs, what happens is each quadrant you move over. So if you go 90 degrees, you switch the coordinates, and the sign is whatever the sign of the quadrant is. All right. So what I mean by that is if I go from quadrant 1, say I have the point 3, 4, and I want to go to quadrant 4, which would be 90 degrees clockwise, I switch the coordinates, make it 4, 3, and in quadrant 4, the y-coordinate is negative, so the y-coordinate now becomes negative. So that's what we're doing. We're just switching the coordinates and changing the side, we're keeping the sign of the quadrant that we go into. So if I have x, y, and I switch the coordinates and the y-coordinate becomes negative, that first coordinate, well, that means we're in quadrant 2. So this is quadrant 2 because that first coordinate is negative. That means we went 90 degrees and we went counterclockwise CC. If the coordinates go back to where they are and are both negative, that'd be 180 degrees. Now it doesn't matter, 180 degrees is 180 degrees, right? It can go either way. This next one would be 270 degrees counterclockwise or 90 degrees clockwise. Okay, the 270 counterclockwise would be it could be 270 clockwise as well. And if we go back around, we just went 360 degrees all the way around. So here's an example. Let's take this figure and rotate it 270 degrees clockwise, which is in this direction. So we're going to end up in quadrant 2. So we're going to end up over here. So I've got A is at 0, 2. B is at 1, 4. C is at 4, 2. And D is at 3, 1. So I'm moving the quadrants 1 over. And in this quadrant, x is negative, y is positive. So I'm going to flip the coordinates. So A becomes 2, 0, and the x is negative. So A prime is at negative 2, 0. B prime, flip the coordinates. The x is now negative, so it's going to be at negative 4, 1. So x is going to be at negative 4, 1. B is at negative 4, 1. C, flip the coordinates, is going to be at negative 2, 4. So that's at negative 2, 4. Is C prime. These are all primes. And D goes from 3, 1 to 1 to negative 1, 3. So this is my D prime. And there is our rotated shape. So you can go 270 degrees, or like I just did, we just did it where we went the opposite direction. We go into that quadrant. Since it's 90 or 270, we flip the signs, or take on the sign of that quadrant. I think that's the easiest way to look at it. So here's a couple other practice problems, and I'm not going to spend a ton of time on this. So 180 degrees clockwise, all we do is we switch the signs. So Q prime becomes the point at 7, negative 7. So it goes from up there all the way down into the second quadrant. So we're just going to deal with that. So it comes down into the second quadrant, or this fourth quadrant, and the signs just switch. So R prime would be at positive 2, negative 7, so on and so forth. And you can probably do that on your own. And the next one here, if we're rotating 90 degrees counterclockwise, we're moving into this quadrant, the third quadrant. Third quadrant, signs are going to switch, or coordinate switch, and the signs take on that coordinate, negative, negative. So Q prime would be at negative 7, negative 7. R prime would be at negative 7, negative 2. So Q prime is at negative 7, negative 7, way down here, negative 7, negative 2, and then we're going to be up here, 3, 4, we're going to be at 4th. So it's going to look something like this. So that's how that would work. So there's our kind of introduction to reflections and rotations. I think it's relatively straightforward if you think about what's going on and kind of these tricks that we showed you on this. Make sure we know what vertical and horizontal is. Now, if you have to rotate around a point that is not at the origin, sometimes you'll have a shape like this, and we want to rotate around this point, what we'll do is we'll make up an XY coordinate plane and kind of rotate it around that point like that. So that's a little trickier. If you think about it, you can probably deal with that. So that's our lesson on rotations and reflections. Make sure you do the homework and practice it. Get used to what happens with the signs, and you should be good to go.